Good morning, fifth grade. We're going to talk a little bit about how we compare fractions with unlike denominators. I've taken this sample problem from your homework and remembering book, and we have denominator of 8 and a denominator of 3. This doesn't fit in with the problems we talked about yesterday. They don't have a common denominator and they don't have a common numerator, so we're going to have to figure out a different denominator that I can take the 8 and the 3 and change it to in order to compare them. So I'm going to start with thinking about multiples of 3 because I know that there's 3 times 1 is 3, 6, 9, 12. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. And I said 8, so that kind of perked up my mind thinking, well, I have an 8 here, maybe that's going to be the common denominator. So 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. So I see that this 24 is going to be my least common multiple that 8 and 3 have in common, and that's what I'm going to change them to. So I'm going to take 6/8 and multiply it by a fraction equal to 1 so that it becomes a denominator of 24. I'm going to do the same thing with 2/3. 2/3 times a fraction equal to 1 is going to give me a fraction with a denominator of 24. I'm going to write my 1 here so I remember I'm making this a fraction equal to 1. And then I'm going to go ahead and think 8 times something is 24. And it's a 3, 3 over 3, 6 times 3 is 18, 3 times something is 24, I know that's 8, fraction equal to 1 is 8 over 8, 2 times 8 is 16. So now I see that I have two fractions with common denominators, and that's how I compare them. So 6/8 is equal to 18 24ths. I got my circle in the middle, and then I had 2/3, which I know 2/3 is the same thing as 16 24ths. They are equivalent fractions. And since these two fractions have common denominators, I'm just looking at the numerator. 18 is greater than 16, which means 6/8 is greater than 2/3. And that is how I compare those two fractions with unlike denominators. Here I have another two fractions that have unlike denominators. I have 10 and 15. So I could multiply these two together, just like we did with the 8 and the 3, but that's a really, really big number. So I know that there has to be something else that 10 and 15 have in common. So right now I'm going to go ahead and I'm going to list some multiples of 10. 10, 20, 30. Oh, and I kind of can see already that that 30 might be super helpful because 15 times 1 is 15 and 15 times 2 is 30. So this shows me that the denominator that I can change it to is 30. If I multiply 10 and 15 together, I get 150, and that's a lot. So I don't even need to use a fraction or a denominator that big. So I do need to change these two to common denominators of 30, and I'm going to multiply by a fraction equal to 1 as always. Same thing with 11/15. I'm multiplying by something to get me to a denominator of 30. I'm drawing my 1 behind because I always want to make sure I'm remembering that I'm multiplying by a fraction equal to 1. So 10 times something equals 30, and I know that's 3. So I have to do the same thing on the top. 7 times 3 is 21. So 7/10 is equivalent to 21/30. 15 times something gives me 30. That's going to be 2. I do the same thing to the numerator as I do to the denominator. 11 times 2 is 22. So now I see that I have two fractions, 7/10 and 21/30. Those are equivalent. They mean the same value. And then I have 11/15, and I have that is equivalent to 22/30. Now that my denominators are the same, I can go ahead and compare the numerators. So I'm looking at 21 and 22. 21 is less than 22. So that means that 7/10 is less than 11/15. Last example I want to show you is when I have two denominators, but one denominator I get to leave on its own. So I look at 3 and 9, and I know that those are numbers that are very compatible. If I think about multiples of 3, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. I already have a 9 right here, and I have a 9 right here, which means I don't have to change 4/9. The only fraction I need to change is 1/3. And I'm going to get that to a fraction with a denominator of 9. Always when I make equivalent fractions, I'm multiplying by a fraction equal to 1, because that's how I know that the value of my fraction does not change. So I know 3 times 3 is 9. I do the same thing to the bottom as I do to the top. 1 times 3 is 3. So this tells me that 1/3 is equivalent to 3/9. So if I take 1/3, which I know is equivalent to 3/9, and I compare that to 4/9, I see that 4 is bigger than 3, so 4/9 is greater than 3/9.